Hello and welcome to this AOS-CX 10.12 version update. I'm Kamal Takodra. I'm a technical marketing engineer in the Aruba switching business unit. So this is part 2 of 2 where we're covering IPv6 Multicast VXLAN updates. In part 1 of 2 I covered IPv4 Underlay with IPv6 Multicast in the overlay. This update now covers IPv6 in the underlay as well as v6 multicast in the overlay predominantly. I will reference part 1 extensively in this update, and please refer to part 1 of 2. I'll only cover primarily the differences between the v6 underlay and the v4 underlay. Effectively, the overlay is very similar, so we won't be duplicating covering that and making this update a bit shorter. So in terms of the agenda, we'll do a quick overview. In terms of use cases, please refer to part 1 of 2, which covered both the IPv4 and IPv6 underlay, and then I'll repeat the details and caveats, which are the same for both the IPv4 and IPv6 underlay. And then for configuration, I'm only going to cover the differences, in fact just what the IPv6 underlay elements are. And again, please refer to part 1 of 2 for the more detailed configuration. And then we'll go and cover the best practice, which are pretty much similar as well. And then we'll finish off with a short demo. Go into the overview. So as I said, I covered a single fabric with the IPv4 underlay and mainly covered IPv6 multicast in the overlay. We've changed the title a bit here. Again, now we've got a single fabric that we're talking about today with an IPv6 underlay. And in 10.11 we introduced that feature which supported IPv4 unicast in the overlay, but we didn't really talk about it that much, so we've included it here. And we've also got IPv6 multicast in the overlay, and they obviously go hand in hand. You can't do one without the other in the overlay. But remember that regardless of the underlay, the overlay is independent of the underlay. Okay, so what have we got existing? And I've covered some of this already, but in 10.11 we introduced a single fabric IPv6 underlay supporting unicast. So that really meant from previous features we have now dual stack IPv4 and IPv6 unicast in the overlay, and the platforms that were supported at 10.11 were the 6364 and 8360. Don't want to try and confuse it, but we also have unicast and multicast support in the overlay as general on these platforms, and I'll try and break that away in the next slide. That's mainly for the IPv4 underlay, but obviously there's some overlap in some of the products. So what's new? Well, the new thing is we're supporting IPv6 underlay, and that's for the first time supporting unicast and multicast. And that means in terms of protocol support, we have layer 2 multicast, listener discovery snooping, which we'll get into later. And then we're supporting L3 PIM sparse mode. So with all of that, that now means for the v6 underlay, we're supporting a dual stack, both unicast and multicast in the overlay. We also will have support for VSX as a border VTEP in these, just like we did for the IPv4 underlay. And you can see I've got the word extension in here because you will see that used in some of the documentation, and that means we've got a connection to a non-VXLAN network from a border VTEP. So for the IPv6 underlay, we are supporting 3 platforms as listed here. So putting that all together, let me take an example here in this table. So example, if we look at the 6400, which supports both the IPv4 underlay and the IPv6 underlay, all the overlay technologies here on the left, regards to reference to multicast, are supported for both the different underlays. However, we take an example of the 8100, which only supports the IPv4 underlay currently. Then from a overlay perspective, we have the IPv4 underlay and then all the overlay technologies, which includes both IPv4 and IPv6, are supported in the specific overlay. So that should give you a better picture of what's supported, and please refer to our public feature navigator, which you can get all this information from anyway. So let's go across to some of the details and caveats, and these are applicable for both v4 and v6 in the underlay. So the multicast implementation we have here is proprietary, and the fabric for multicast must only include CX switches for VTEPs. We support both layer 2 and layer 3 forwarding for EVPN VXLAN with the Aruba CX switches, and the IPv6 overlay supports multicast listener discovery version 1 and version 2. AOS switches default to version 2 and is backward compatible with version 1. So very important to understand that the layer 2 multicast data streams are sent by sources to VTEPs only to remote VTEPs where there is an interested receiver in the same VNI. We must use MLD snooping to stop flooding within that VNI. So our implementation supports only PIM sparse mode for v6. We support border VTEP as I showed earlier in the use case. We do not support multicast over static VXLANs, and we don't support static multicast today. IPv4 MSD and any cast are not supported in a fabric, as well as PVLANs are also not supported in a fabric with multicast. Okay, so let's go into the configuration which is specific to the v6 underlay. So I'm using this basic setup here where we've got a 2 access switches, or leaves if you want to call them, and we have a spine, and I've got a snippet of a configuration on the right. Now it's very similar for the overall structure, so I'm just going to point out some key points that are different. So the first thing is, obviously what's different is we've got an OSPF version 3 underlay, and you'll notice that I've not actually got an IP address on my actual link between uplink here, which is going from my leaf to spine. I'm using a link local address that is self-generated by the switches themselves. So that's the first difference, and that's what the LLA stands for, link local address. So I've got link local address on my uplink to my spine. That's not mandatory, but it's just to show that we can do it. Some customers might want that if you want, you can put your own v6 link local address on there as well. So that's the first thing. The second thing that's different is that under the VXLAN interface, we have a keyword mode IPv6, which now specifies that we are using v6 in the underlay for connectivity, and therefore you need to put in a v6 address as the source. And you can see on these this diagram, I've got loopback 0 here and loopback 0 on access 2 being used as the endpoints. And again, on the spine, I'm also using a v6 address, but that's for the underlay. Okay, so we've now, in terms of the VXLAN VNI mappings, it's very much the same as it was for v4. Then the next thing we have is we've got OSPF v3 for the underlay, and I've simply just put a router ID on that, as well as for the BGP has a router ID. Now, the standard says that the RFC says that the router ID is a 32-bit address, so we just use a 32-bit address. We don't have to have that address existing on the switch, so it can be an address. It doesn't have to be a loopback existing on the switch. You can see I've got no loopback. It might be difficult to see, it's a snippet, but I've put it in the commentary that the router ID can exist without having the actual loopback on the switch. So they're the main differences in terms of the configuration for setting up the v6 overlay, but let's have a quick look with VSX as well. So no real differences here. I just wanted to bring this up because it was quite important in terms of there are some subtle differences. So I've got a unique loopback here, which you'd expect for the control plane, and then I've got a anycast or a shared loop back for the data plane, because we need to show that everything's coming from one VTEP. Effectively, you can see that I've got the mode here, so there's no real differences. And something I wanted to call out is you must have the redistribute MAC or SVI, and please refer to the previous slide deck, part 1 of 2 on that. But really, in summary, the reason that we need to redistribute MAC or SVI is that Multicast needs an awareness of the system MAC, and that can be because of when data comes across an ISL link and it's decapsulated, the system MAC will appear on one of the VSX nodes, and that's not carried normally. So we use the redistribute MAC or SVI to make sure the VSX nodes have awareness of the system MAC for things like queries, PIM routers, and static joins use this system MAC. So please refer to the previous slide deck that I went through in detail around that. And that has to be, so when you do have VSX in the fabric, you must have this redistribute MAC or SVI on all of the VTEPs within that fabric, not just on the VSX. I know I've shown it here in the configuration. I don't have the space to show it all, but it must be on all devices if you have VSX VTEPs within the fabric. And there I've called out the system MAC awareness. So that's the underlay. So now what's applicable to both IPv4 and IPv6 in the underlay in terms of configuration? I covered all of this in part 1 of 2 last session. So just for quick reference, and to call it out, so for the overlay, so we enable MLD snooping under the VLAN context. When we have PIM sparse mode with the overlay and a bootstrap router and a rendezvous point, we have IPv6 PIM-v6 sparse node enabled. Then we have some router PIM-v6 contexts where we can define the RP and the BSR and give them a specific priority. The same also went for when you're having it in a VSX environment, no different. Again, refer to part 1 of 2. And then we introduced this IPv6 PIM6 sparse VSX virtual neighbor, which is no different to when we have that for v4. The only difference is we've got a PIM6 here, again covered in part 1 of 2. This is here for reference. And then we also covered the configuration of border VTEPs using a VSX configuration, both an layer 2 connection or an extension, as I mentioned earlier. And then we talked in part 1 of 2 also when we had a layer 3 SVI connection between VXLAN and non-VXLAN networks, where we introduced a bit more configuration, which was the PIM-v6 sparse VSX virtual neighbor, which was introduced earlier, but we also have to have some VSX active forwarding in that setup. And then finally, the third way of connecting was with routing on ports or SVIs with point-to-point connections, where we have to add this command for synchronization of the data path which is IPv6 PIM-v6 sparse data path auto encode. So all of this was covered in part 1 of 2, and it just shows you what the what the similarities are between the two overlays. So in terms of best practices, this is also covered in part 1 of 2. There's only a minor difference, so let's call these out too. So when we're using MLD snooping basically to stop flooding. I can't emphasize that enough, otherwise you are going to get too much traffic everywhere when you have a receiver. The only difference here is that we've got an IPv6 underlay, so make sure that's operational. Something I didn't really mention about the local SVI and the local MAC redistribute for the VSX, for the system MAC awareness is when do you use local SVI and when do you use local MAC. So you use local SVI when you've got both L3, L2 in use, so i.e. when you're using an L3 VNI. And then if you're only doing a stretch of L2, so you've got a single VLAN stretching across your fabric between different VTEPs, then you can just use the redistribute local MAC. And then we've got this PIM-v6 VSX virtual neighbor command when you've got VSX lag SVIs that need to be enabled. And then this is really across the whole fabric environment that you need a virtual MAC across all the VTEPs if you're using the distributed L3 gateways. And then where do we place the RPs? Is that they can be either in the external non-overlay network. So if a customer's already using an RP, they can have that in their non-VXLAN network, and we can connect with them with a border VTEP. Then positioning of the rendezvous point or the bootstrap router can be on the border fabric or the border VTEP. But it's all about, it depends. You can't predict where your sources and receivers are, and that's really a general recommendation, is to put the RP as close to the source as possible, but that's not always practical. Same for the IPv6 underlays, that both the RPs or BSRs are only supported on the platforms shown: 64K, 8100, 8325, 8360, 8493. Note that the 10K, 10,000 is not there. And then some of you SEs, or maybe testing in your labs, you can have an RP or BSR on a standalone device. So this is only applicable when you're using a VSX environment. Now, we came across this IPv6 PIM6 sparse VSX virtual neighbor. Don't put it on the point-to-point SVIs between your border VTEP and your extended nodes. Otherwise you can get data loss. And then we have that auto include that we have between the peers in a VSX node, again all covered in part 1 of 2. And then we've got the different use cases, which also includes added the VSX with MLD snooping and PIM sparse mode too. So that's the best practices. That really covers the IPv6 underlay. So I'm going to now switch to the demo. So let's just have a quick reminder of what we have. So you should have seen this throughout both the part 1 of 2, but part 2 of 2. You can see that I've got this leaf and spine. I've got a link local address between my spine and access, or spine and leaf, with a self-generated address. And I've got a few hosts here. So the first thing I'm going to do, just change it up a tiny bit, make it different from the last demo. We'll put some unicast in here as well. It's just something extra to show. So I've got a host here in VLAN 10 sitting off access 1, and I've got on VLAN 20, and I've got a host 3 in VLAN 10 sitting off the other access switch. So I'm just going to browse to this guy using both V4 and V6, and then just show you some output from that. So this has got a web server on it, and then what we'll do is we'll also do some multicast across here. So it covers off, in terms of a demo, both V4 unicast and multicast. So if I quickly go across to here and I start off a Wireshark trace, so I'm on this VLAN 20. I'm just gonna just hit this web server, and we can see that I've got HTTP traffic that's come from this host 10.20.2150 to 10.10.160. It's just showing and demonstrating that we're supporting from an application perspective IPv4. And then let's stop that and start that again. And then let's go across. So I'm going back to this same host here, going across here, going across the L3 VNI, by the way, because I'm different subnet, and then same host, which is dual stack, and going to this address 2001 DB8 10.10.10 : 160. So I'll just refresh that and then go across to my Wireshark. Now you should, yeah, we can see that's coming back. We can see the HTTP, so we can see that's obviously the same host. So it's come from this host ending in 20 AB:51C, and it's going across to this remote host. And if we check this host, do an IP config/all, we can see from the IPv6 we had the 202150, and then you can see my IPv6 address is 2001 db8 202020 ending :51C. So that's really basically showing that I'm able to have some unicast traffic across that IPv6 underlay. So let's have a quick look at so I'm now going across to this access 1 switch. So bear with me while it loads on. Okay, so I've just done a show IPv6 route, and what I can see is my loopback on the other side being learnt by OSPF here. You can see the 1::160 and ::161, and then you can see another loopback 2001 db8 192.168::1, all being learned from 1151 with a next hop that we really don't know. So this next hop is the link local address of my next hop, which was self generated. So I can go across if I was troubleshooting and I'm not familiar with that link local address, because I've used a self-generated link local address. So you can see on this in uplink, I've got no IP addresses. I've self-generated that, and I've done the same on the spine. But just looking at that, okay, so I have got some IPv4 addresses in there, but I'm not using it because I'm not using OSPF between them. But you can see I've got no IPv6 addresses, but I've still got a next hop. So I can look at that just by looking at the specific interface. You can do a show IPv6 interface and then the interface name, and you can see I've got this link local address that's valid, which has been self-generated by my underlay. You can see it is CC1C C300, which is this link local address that I've learnt on my access switch spine. So let's go into and now repeat some of the demo that I did last week, just to finish things off. So we can now look at the V6 routes in that specific VRF, and there is a bit of a difference. Obviously now when I'm looking at my hosts or prefixes I'm learning from the other side, the next hop is my V6 address in the overlay. So what I'm seeing is from this switch, I'm seeing, you can see this specific host, which is ::160 here, and I'm learning it from 192.168::160 here from that loopback. So that's the difference in the IPv6 underlay. Obviously the next hops are going to be V6 addresses, and then I can go a bit granular if I just want to look at the dynamically learnt routes, I just put the BGP into there too, and you can see very similar thing, but I haven't seen my local or connected addresses here. Again, I showed this last week, but obviously this is now a V6 underlay. So we're going to look at the layer 2 EVPN routes, the type 2 routes that I've learned from the other side. So these are routes I've learned from here, and I'm sitting on this switch here. So I showed this in the slide deck, but it's great to see this live too. You can see I've got the MAC addresses. I've got my you can see that the MAC address is the same, and you can see it's a dual stack host. It's got both a V4 and a V6 address. Obviously, the difference is the next hop is now a V6 address on the VTEP. And then we can do something similar just to look at prefixes. Not 1 second. Okay. We can look at type 5 routes, and I can see from the L3 VNI perspective, I've learned this 2001 DB8 707070 from that same switch. I know that that is a loopback that I've created here on this switch, which is actually my rendezvous point I've configured on here. Again, look at the configs in part 1 of 2 in terms of the overlay. The only differences are that the next hop is now a IPv6 address. So I think finally what I'm going to just show you is some multicast operating in this V6 underlay as a bit of a demo. I've done all the troubleshooting and shown that. We'll look at how MLD impacts the system too. So what I'm going to do is I'm going to start a multicast source from this device on this switch, and I'm going to have a receiver first of all in VLAN 10. So let's kick that off first of all. So start kicking off this source. Get onto a receiver, this node here. Okay, so we now got multicast traffic appearing. Source here, receiver here in the same VLAN. Now what I'm going to do is I'm going to jump onto this host and show that actually it's not receiving multicast traffic, and then I'm going to switch off MLD and we'll see some flooding happening. So start the Wireshark trace off first. So this is in the same VLAN. Okay, get onto my access switch. Okay, I'm just going to switch off MLD snooping in that VLAN. Go back to that host. You can see now I am getting traffic flooded. One thing I didn't say, that the actual multicast that I'm sending is to this specific group FF38:1:1. That's the source group I'm looking for, and it's being flooded even though I haven't started any type of interest in that join. So let me switch that back on again. As soon as I've done that, we should see that it's curtailed the traffic now and blocked that group. Now I can, on this host, make a specific request. I've made that request, the video traffic's coming, and now it's to my accord in terms of asking for I've joined that group. So let me just stop that traffic. So that really ends the demo, because in terms of the demo from the previous part 1 of 2 covered all the aspects of troubleshooting. So I would look at that longer demo. I've shown some of the differences here in this demo in terms of the IPv6 underlay, and then just covered it off with just showing some multicast operation. And obviously I've shown some unicast here as well, which is quite useful to see and just proves that it all works. So let's finish off with some additional resources. So I'd recommend you to go to our Aruba network support portal, and if you search for the latest multicast guide in the search bar, that will bring up the guide that will have details of both the IPv4 and IPv6 underlay with some really good examples. Also, please refer to my previous update on IPv6 multicast, which is part 1 of 2 of this series. And finally, thank you for watching, and I hope that was useful for you.